26b, combinations of functions. Guys, we've done composite functions before. But what we're going to be doing in this section is we're going to take functions and plug those functions into functions. Okay. So, and it's not difficult. Just pay attention to what you're doing. Okay. Another way of combining two functions is to form the composition of one with the other. For instance, if f of x is x squared and g of x is x plus 1, the composition of f with g would be f of g of x. Notice that g of x is x plus 1, right? So if g of x is x plus 1, then f of g of x would be the same thing as saying f of x plus 1, meaning take the f function and anywhere you see an x, change it to x plus 1. That's all there is to it. Okay, so we took g of x and plugged it in for x. So x plus 1 squared. And then, of course, you could multiply this out, right? Foil it, expand it, be good to go. This is how it's written a lot of times. F, that is read f of g. Okay. Anytime I see this, I'm going to rewrite it this way. Because to me, that makes more sense. That means f of g means take the g function, plug it into the f function, and compute. Okay. Questions on that? So that's the main concept of what we're doing in 2.6b. The composition of function f with a function g is f of g of x, which is the same thing as f of g of x. I read these the exact same way. It's not fog and Goff. Okay. The domain of f of g is a set of all x in the domain of g such that g of x is in the domain of f. And then this lovely picture, which kind of describes what's going on there. Okay, here's three problems. I want to know what f of g of x is. I want to know what g of f of x is. And I want to know what g of f of -2 is. Part A. First thing I would do is rewrite that. F of g of x is f of g of x. Order of operations, what do you do? What's order of operations? Parentheses, right? What if you have stuff inside parentheses? What do you do inside the parentheses? If there's more parentheses, you work inside out, right? So if you look at it this way, that's what we're going to do. To figure out what f of g of x is, the first thing we have to do is figure out what g of x is. Well, what is g of x? 4 minus x squared. So in place of g of x, I'm going to write what g of x is. So I have f of 4 minus x squared. What does that mean? I took f of x and changed f of x to this. So what do I do with the 4 minus x squared? I changed x to 4 minus x squared. So change x to 4 minus x squared. So I have, here's an x. So in place of x, I'm going to put 4 minus x squared plus 2. Now, it's best practice when you're plugging something in to put it inside parentheses. In this case, the parentheses aren't needed. But for practice and when I'm working the problems, I'm always going to put them in parentheses. 4 minus x squared. Okay, I can't do anything with that. So now let's ignore these parentheses. Can you do anything with what's left? 4 minus x squared plus 2. Okay, so what's my final answer going to be? Okay, but I'm going to write it in descending powers. Negative x squared plus 6. Is 6 minus x squared wrong? No, it's not. Okay, but to write it in descending powers, this would be the best way to write it. All right, g of f of x. What that means is I'm going to take the g function and plug f of x into the g function, which means I've got g of f of x. What is f of x? F of x is x plus 2. So I'll plug x plus 2 in. So now I know that I'm looking for g of x plus 2, meaning replace x with x plus 2. So here's my g function, 4 minus. There's an x, but my x is x plus 2. And that x value is squared. Are those parentheses important? Absolutely they are. Because now I've got this binomial that's trapped, right? This binomial is being squared. So let's square that binomial. Pay attention to that negative sign. It's going to cause you to miss problems if you don't. So what I recommend you do is take the 4, take the minus, and go ahead and open parentheses. Now let's take care of x plus 2 squared. What is x plus 2 times x plus 2? First times first, x squared. Outside times outside, 2x. Inside times inside, 2x and 2x. Last times last. Okay. Do you see how important those parentheses were? If you did not put those parentheses, you're going to have a negative x squared, but then your 4x and your 4 are going to be positive, and that's going to be wrong. So now we will distribute that negative sign. That gives me 4 minus x squared minus 4x minus 4. Combine like terms, put it in order. What do we get? Negative x squared minus 4x. And then 4 minus 4 is gone, right? How are we doing? Okay. Okay. Notice C says g of f of negative 2. If I wanted to, I could, since I've already finished part B, all I got to do is plug the negative 2 into this, and I'll give me the answer. Okay. Normally, if it just gives me this problem, though, I'm not going to do it that way. Let's write out what this means. G of f of negative 2 means g of f of negative 2. What is the value of f of negative 2? 0, right? If I took f of negative 2, that's going to give me negative 2 plus 2, which is 0. So g of f of negative 2 means the same thing as g of 0, because that is the value of f of negative 2. So how do you do g of 0? 4 minus 0 squared, and I get 4. Into that? Most of the time, you're not going to work through this and then plug the number in, unless you had a whole bunch of problems that said, find g of f of 6, 3, 12, negative 7. In that case, I would work it out, simplify it first, and then plug those numbers into this. Okay. If I plugged negative 2 into this x, do I get 4? Negative 2 squared. Negative 2 squared is 4. Negative 4 would be negative 4. So that's negative 4. Minus 4 times negative 2. Negative 4 times negative 2, 8. Negative 4 plus 8. So you are going to get the same thing. You saying just do it this way or here? If I only had one problem, yes. But what if they said, I want you to find g of f of negative 6, g of f of 12. I want you to find g of f of 1.2. So now you're gonna have to do this and then to do it again and then do it again. Whereas you could have done this once and then just plugged into that. So if you're doing the whole bunch of problems, then that would actually be easier. But if I'm only doing one, I would do it this way. Other questions? Okay. Here's part A. Same answer we got, right? I hope. Here's part B. This is 2.6b. Because we already did part of 2.6 earlier. And that was part C.
No, he was talking about on the board. We did part C. Like the pop.
Okay, so it says in example 5, which I don't know exactly what problem that was. You form the composition of two given functions. In calculus, it's important to be able to identify two functions that make up a given composition of functions. For instance, if h of x is 3x minus 5 cubed, is the composition of f of x equals x cubed and g of x equals 3x minus 5. Can you see how those all relate together? If f of x is x cubed and g of x is 3x minus 5, can you see that this right here is g of x? And that g of x value is cubed. Okay, so that would be f of g of x. And in calculus, we do decomposition. You know, here's what the problem is. Where did this problem come from? This problem came from 3x minus 5 and x cubed. But that's not the only way it could have been. Someone else could say, well, this actually is composed of three different functions. One function is x. One function is x minus 5. Another function is x cubed. And I could actually deconstruct that h of x into three separate functions if I wanted to. Okay. Normally we go to just two though. To decompose a composite function, look for the inner function and the outer function. So in the function g of x is 3x minus 5 is the inner function, and f of x is x cubed is the outer function. Yes. Okay, word problem. The number n of bacteria in a refrigerated food is given by this function. N of t is 20t squared minus 80t plus 500, where t is between 2 and 14. So the domain of this function is 2 to 14. That makes sense? Can I use 73? Not in the domain. Can I use 0? Not in the domain. Can I use 1? Not in the domain. Can I use pi? 3.14 is in the domain, right? Okay, so we've got the domain established. T is temperature of the food in degrees Celsius. When the food is removed from the refrigeration, the temperature of the food is given by T of t equals 4t plus 2, where t is between 0 and 3, talking about number of hours. So find the composition n of t and interpret its meaning in context. Let's do that. What is n of t of t? Say that again.
N of t is 20.
It is.
And then E would be 4.
So I need to replace, I'm going to take my n of capital T, okay? And anywhere I have a capital T, I'm going to replace capital T with capital T of lowercase t. So I have 20. Here's a capital T. What does that capital T need to be changed to? 4t plus 2 squared minus 80 Oh, another capital T. 4t plus 2 plus 500. Are all those parentheses necessary? Absolutely necessary, right? All right, let's go ahead and simplify this. 20 times, I have 4t plus 2 squared. First times first. We can't distribute yet. 16t squared. Outside times outside. 8t. Inside times inside. 8t and 8t. 16t. Last times last. Okay. Now what? Now I can distribute the negative 80, right? So negative 80 times 4t. Okay. Negative 80 times 2 plus 500. Am I doing anything difficult? Really? No. Okay. Next step. 20 times 16t squared. Plus 320t plus 80 minus 320t. You want to go ahead and combine those right now? Okay, plus 340. Can we combine anything else? Okay. 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 So n of capital T of lowercase t is 320t squared plus 420. Is that all clear? That's part A. What does that mean, though? What does n of t equal 320t squared plus 420 mean? Okay, and what does lowercase t represent? Time and hours, right? Okay. So the amount of bacteria in hours is going to be found by this formula. And this is the time since it was removed from the refrigerator, right? Okay, so that's in context. Part B, find the time when the bacteria count reaches 2,000. Where's the 2,000 go? Yeah, that's this part, right? So if I have 2,000 equals 320 t squared plus 420. It's a quadratic. How do you go about solving quadratics? We actually could use the square root method on this because there is no t term. Didn't think of that. But we could use the square root method. Sure. To use the square root method, you would subtract 420 from both sides. So 2,000 minus 420 would be 1580 equals 320 minus 20. Divide both sides by 320. And since I'm looking for time, do I want to have square roots in my answer? Are we okay with rounding if we're talking about time? You know, if I asked you how long is it going to take you to do something, you're not going to say the square root of 3 hours, right? Unless you're a total nerd. So t squared equals what? 9 what? Not, is that exactly or? Okay, and then how do you get t by itself? Okay, now this is a quadratic. If I take the square root of both sides, what's going to happen? Plus or minus, right? Now I'm writing that down for now. Go ahead and finish what you're about to say. Okay, so we're gonna throw away the negative, but I'm writing down the negative because technically it is part of the answer of this quadratic, which makes no sense to our problem because t has between 0 and 3. Okay, so that's why we're going to throw it out. And so we get plus or minus. Okay, and then just as was stated, yeah, it's not going to take negative time, right? So we throw that away. So how long is it going to take to reach 2,000 bacteria? About 2.2 hours. That's exactly what we did. I think that's the same answer we had. Yes, I hope. Bacterial count reached 2,000, 2.2 hours. Note that when you solve this equation, you reject the negative value because it's not in the domain of the composition function. Okay. And that, folks, is the end of 2.6b. Okay.
15 G's for that.
Let's do number 3. It says find two functions f and g such that f of g of x equals h of x, and h of x is the cubed root of x squared minus 7. So remember, f of g of x means f of g of x. This is a decomposition. What function do you see on the inside of this function? X squared minus 7, do y'all agree? So because g of x is the inside, I'm going to say that g of x is x squared minus 7. Well, if that's true, then what's the outside function? What's f of x? Cubed root of x. That's all it is. Okay. Let me ask you this. Is that true? Okay. Now, which one's the most obvious? The blue one, the one that y'all told me, right? But I'm showing you this just so you know that there's not necessarily a right answer to this question, the way it's stated. Okay. It's probably going to go for the obvious. Mm-hmm.
Wait, is that really just the reverse of what we just did?
Number 3.
Yeah, the red. Isn't it like the flip?
No, it's the same. It's the same but different.
No, I mean, like, this is the same thing you just put down, but like flip.
No, because x squared is still inside. Okay.
One is just the cube.
Yeah. Y'all feeling okay about this? How about g of g? G of g would be g of x, meaning take the g function and anywhere you see an x, replace the x with the g function, and that's okay. Okay, so the g function is x minus 9. There's an x, so I'm going to change the x to what? And that would be? Okay. Does order matter? F of G and G of F are different, right? Order matters. Okay. All right, folks, I'll stop the recording.